So first of all, the 2 pages of this packet that you're looking at, basically you're just doing one side and the other, 6-1 and 6-2, and the rest of that paper is just to provide space for you to do the work that you need to do.
Wait, do we
Couple,
cross out 7 and 8?
and you can cross out on this one, not 7 and 8, yes, and it also says it on the answer sheet. In addition, though, you can. We're not going to do number 10 and number 11.
Oh,
All right.
okay.
I'm hoping that we're okay with with number 1, 2, and 3. You're basically plugging in -2 and 3. With numbers 4 through 9, you need to graph at least 3, if not 5 points. So 3 to 5 points. Typically, the points that you're going to be using are -2, -1, 0, 1, 2. Those points, because of any of these exponential functions, what really most of what happens in that range. The problem is -2 and 2 sometimes give you numbers that are so huge they're not on the graph. Okay, so that's why I'm saying try to get at least 3 points to graph it. Are there any questions about how to graph these? Will, you were talking a little bit about. I mean, do you understand what I mean when I did plug in a couple points?
Yeah.
Right.
I did it. Don't worry. I did the 1 through 2 thing.
I mean, this one here, for instance, number four, the points on this one can get kind of crazy at -2 and 2, but at least you can do 1, 0, and -1. So 5 to the 1 power is 5 to the 0 power is
1.
and to the -1 is
0.25.
0.20 actually,
Really?
but it's 1/5. Okay, 1/5. So at least you can get those 3 points for that graph, and that's going to be, in terms of the test, getting at least 3 points is going to do it. All right. So next, these are the ones that are like what I was talking about before. We saw these actually. What's that? Okay, whatever. So on 14, what we want to do is we want to rewrite it in this form, either in this form, which is a growth form, or in this form, which is a what? Decay. And that means that, you got the growth has the plus sign and the decay has the minus sign. So let's go ahead and do, we can do this one first. So number 14, it says y equals a 5t over 8. What I want to do is to get t by itself. Does anyone remember how I can rewrite this so that I get t by itself? I'm going to go 5 to the what power?
2/8 over t. Yeah.
It's going to be 1/8. Look at that for a minute. Convince yourself.
Oh, yeah.
Okay, I know. Okay. Take a look at it and see if that makes sense. What's t times 1/8? Isn't that t over 8?
Sure.
Yep.
All right. Guys, t over 1 times 1 over 8 equals t over 8. Are we all right with that? And then once you've done it a couple times, it's not so bad. But the idea is to try to get t by itself. To get t by itself, I need to remove the 1 over 8. And then I put that in my calculator. When I put that in my calculator, can you guys do that really quickly? 5 to the 1/8? I'm going to have to do this down here. You guys have space for this. So now this becomes a to the
1 plus.
It's 1.222.
1.222.
No,
So,
but it becomes a 3 because.
all right. Okay, so
But then you gotta subtract that by 1 to get
now I've got one. I got a times 1.223 t. My last step is to rewrite this. It's bigger than 1, so it's a growth. So I need to rewrite it as 1 plus something.
Yes.
1 plus what is equal to 1.223?
1 plus 0.223.
Exactly. With growth equations, it's very easy. It's whatever's to the right of the decimal, right? For most of these. So that is how. So now, if I was to ask you, what is the interest gained? What is the interest rate? 22.3%.
What?
All right. So hopefully at this point you've written this down on your worksheet and you got an understanding of how that works. Before I leave this though,
Wait.
tell me, what would I do? What's my first step with number 15?
T by itself.
I want to get t by itself, so I'm going to write this as a to the 0.4 to the what power?
1/3.
Careful, it's not t over 3, it's 3 times t. It's just going to be 3. Do you see why?
Yeah, because it's.
Because the 3's on the top, right. Okay, good. So you got the idea?
Yeah.
All right. Okay, so I just want to make sure that you had that down. Let's go to the next page. I'm trying to find. Uh-oh. On the next page, I'll tell you what. Let's go right to 13 because this is. Oh, is that my same?
Literally like the same.
That's exactly the same page. Let me see.
Mr. Shy, mine's the different page number.
All right.
I don't know what's going on, but
I have the same sheet twice.
it's okay. It happens. It's the best of us.
Dang it. Okay. Well, anyway, I'll tell you what. Let's go to. I'm gonna just go to the. I'm just gonna go to the sheets that we do the answers on. So, on number 3-2, I'd like you to go to number 11. So, I'm gonna go to the place where we have the answers to number 11, and it's right here. Correct?
Oh my god.
So number 11 says y to the e to the negative 0.5 x. So on this one, we've already actually
I thought we were in.
we've already done this one. But Jillian, what would I do with this one to start it? It's gonna be. I'm gonna rewrite it as y equals in parentheses. Can you see it? I want to get the x by itself, right? Can anyone tell me what I'm going to do on this one? I'm going to write it as e to the what?
E to 0.
Or I could just write, or in this case, I can just go ahead and write it as negative 0.5 to the x. All right, guys, this is exactly the same method we used about 3 minutes ago. All right, except instead of a 3 for a base, we have an e for a base, but we have that in our calculator. So, what is this equal to? It's going to be less than 1. I can guarantee that. Y equals,
Decay.
right? It's going to be 0.
Wait, what?
0.606, right? To the x. So this is the tricky one, though. Now I've got to write this as 1 minus something. 1 minus what equals 0.660.
Wait, 0.660.
30,
Negative 3.
304?
What? No, 3, 9.
393?
It's on the calculator, bro.
Just subtract.
It's 393.
What do you do, guys? You subtract it from 1. 1 minus 6.6. 0.66.
It's 393.
393. Okay, so 0.393. So, okay, between all the giggles, let's see if we can make sure that we understand what just happened there. It's exactly the same thing. I wanted to isolate the x, get it by itself outside the parentheses. So I want to evaluate anything that's not the x. And then from there, I can go ahead and write, what's the percentage? In this case, what's the rate decrease of whatever this is?
39.3%.
39.3. All right. So if you have an idea what's going on, maybe you can go. Should I give you a second to try number 10
Wait,
or
what's the sounds like a plan, Mr. Shy.
or number 12? I'm saying, right?
Oh, what's the first one?
Yeah, this is also like the wrong thing.
Oh, yeah, I did the wrong one, so I need to move it, don't I?
Like what? What was the percentage?
Okay.
39.3.
I can't do it.
What could I not do?
I don't know how to grab it. I don't know how to grab it. Okay, right. I did it in the wrong. I did it in the wrong number. Is what Will's saying. So anyway, that was number 10. I mean, I could start you off, but I need you guys to get your.
Our footing.
Well, I need you to be able to see. Do I have the right one? 9. Was 9 a graph? It is, right. 9 and 10. Well, anyway. Okay, so okay. Page 3. I think I did that on the I did that on the wrong page. I did do that on, there was some graphing ones too, but just curious, what do you guys think would be the answer to number 5?
On which side?
6-2. I'm still in 6-2.
Yeah, but on this side?
It's 3e to the 3x squared. Now the question is, what are you squaring, and how does that look?
You're gonna square the 3, but you're just gonna tie.
And I'm going to square the 3x, right? 9e to the,
6.
all right? So that one's, I think the reason that's tricky is I'm thinking, and just because the 3x as the exponent, it's like this big,
Just remember that rule.
this big messy thing. But if you remember the rule and just follow it literally, right? Multiply the exponents. Exponent to an exponent, multiply the exponent. So that's 2 times 3x, which is 6x, right? And so that's a little tricky.
Well, that's easier than the one that has like the negative. Like if it was like a -2, he would have to like flip it all.
If you guys look at number 7, yeah. Does anyone look at number 7? Can someone look at number 7 and see what they did wrong? So in number 7, it says it's very similar to the one we just did, right?
No, did they distribute the 2 wrong?
It should be 6x. It should be just 6x, right?
No, what they did was that they squared.
They squared the exponent, right? Instead of just multiplying it. Very, very good. Okay, so anyway, those are the highlights, and I'm hoping that you might be able to, kind of slip your way through the rest of that stuff. How many people were able to finish the online part? Okay. For which one?
Yeah, would it be 4E?
Number 6. The answer is.
4E.
Wait, which one? I'm sorry. On which page?
It's 4e.
I got
6-2.
yeah.
It's 4e to the 5x, right?
It should be.
I got 45x.
It should be 4e to the 5x.
That's what I got.
Wait, is it just this one sheet? That's it.
No, I'll show you. Okay, well, anyway, I'm gonna stop the recording for now. So if you guys need a refresher, this is not gonna be very long. So I'll throw it on there. Bye all.
Not too bad.
Page. Sorry about that. So let's go. Let me do. Let's go ahead and at least set up number 12. Someone take a look at number 13 and tell me if that's a growth function or a decay function. Number 13 on 6.2. It's growth. And why? Quickly.
Not negative.
Okay, because it's positive, right? And you're going to see in a moment that it's going to give us a number bigger than 1. So we're trying to put this in the form of 1, either plus or minus a rate times a time, or an x. So that's the form we're trying to get it into. So when we say y equals 5e to the 0.6x, what is the 5 in this case? This is something that you want to look at, Felicia, right? It's the a value, right? It goes on the outside. So what we're trying to do is deal with the inside the parentheses part. So what would go in the parentheses? Well, 5 is going to be on the outside, right? On the inside is going to be the rest of the mess, right? And what is that? I shouldn't say t. That's going to be an x, right? So here's the x. So what's on the inside? I got the 5 on the outside. I got the x on the upper side. What's left of that equation? E to the what?
0.6.
0.6. Now you're going to put that in your calculator. 5 times e to the 0.6 is
1.822.
822. Okay, and is it growth like we predicted?
Yeah.
Yes, it is. Okay, now it's always easy with growth, guys, right? Because we need to rewrite this as 5 times 1 plus something, right? And there you go. Now I'm not going to finish this for you because I want to make sure you guys can do that on your own. Okay. So that's one thing that this is one very important task that you're absolutely, if you kind of get it, it makes sense. But you also, I would encourage you to do this on your own. Some of you probably already wrote it in the box, but, or at least try it again on your own. The one that I want you to look at though is number 14. In number 14, what you're going to be doing is you're going to be graphing the equation, and you're going to be figuring out, you're going to graph it in your calculator.
Oh.
And when you're in your calculator, you're going to go and you're going to see what the domain and the range is. All right. So let's go ahead and put this in our calculator. So go into your y equals. Hang in there, guys. You'll keep your notes going with for your friends. Anyway, so it's going to be e to the x minus 1. And you may see something that you're familiar with in a minute. Okay, did I get the x? Okay, good. Now, what I'm going to do is let's graph this on the standard graph. So zoom, standard is 6, I think, right?
It is.
And there's my graph. Now, one of the ways to be able to figure out, let's go ahead and use the trace function, maybe get a sense for what's going on here. All right, so hit the trace button and let's move to the left. And let's see, as I move to the left, what happens to my y values?
Go down.
And they're getting closer and closer to,
It's like a whole
they're getting closer and closer to 0, right? So the idea is what? That's a asymptote. So we know that in the y direction, that graph doesn't go below the x-axis,
Yeah.
right? So what does that mean for? Let's first do the domain. The domain's a lot easier. What's the domain in this case? All real numbers. Excellent. And then the range. So okay, the range is going to be correct. It's going to be bigger than 0. Is it going to include 0?
No.
No. So if it doesn't include the 0, we're going to say, okay, I know that some of you guys are used to the guys from the other class. I'm not going to use intervals on this. I'm going to go x is going to be greater than, y is greater than. Some of you guys did that on the test too, right? Wrote the wrong letter. Y is greater than 0. Not greater than or equal to, right? Because it's a line that approaches that. Okay? So that's the idea for numbers 14, 15, and 16. Graph it on your calculator to get a sense for what's going on. Go ahead and push the trace button. Kind of feel out the graph a little bit so you know how low it goes or how high it goes, right? You know that thing just goes on forever probably. So I know that domain and range drive people crazy. Once you got it forever. And so, just kind of hold on to that. Now, the only other thing that I would be concerned about is, not really, but number 17, it says, in an account to save for college, it says option 1 pays 5% annual interest compounded semi-annually. What does that mean, semi-annually? For 17.
Every 6 months.
Every 6 months, correct. And what would be the balance after 2 years? So we need the formula for compound interest. Does anyone remember what it looked like?
Isn't it the PERT thing?
Oh, it's 8
No, PERT does continuous compounding. In other words, the PERT formula compounds every second. All right, or every nanosecond.
the rate over time thing.
So it's going to be the amount of money that you have is going to be equal to the principal, correct? But inside it's going to be 1 plus the rate over the number of times you compound it per year times
The rate over time.
the number of times you compound it per year times the number of years. All right. So this is a formula that comes up in the ACTs, I guess, right? Is that an ACT thing you had for practice?
Who knows?
Not this. Actually, they don't use this formula. They only use the rate 1 plus rate, right?
Yeah.
So this is a more complex formula. So on this one, so doing A for number 17, let's see if we can put the formula together. What's the principal for number 17 on 6.2? It's on the bottom. $4,000, right? And it's going to be 1 plus.
Wait, so
Let's do A. A is semi-annually, so that means that N equals, for A, N equals 2.
yes.
All right? So we're going to go, rate is 5%. Okay, I'm going to shove that right in there, 0.05. Divided by 2 times 2 times what? How many years?
6. Or no, just kidding.
I think they have I think on this
2
question
years,
for me it's
but-
just 2. All right. So we put that in the calculator. So this is our investment of 40,000 at 5% compounded semi-annually. What would you put in for? What would you replace the 2 for in B and C? In B.
Wait,
We eat.
I'm kind of confused on
Oh.
how you set it up.
Oh, you do,
Well, that one is continuous. So which formula is that?
B would be
The PERT.
0.45, or no,
It's the PERT, right?
0.045.
It's a PERT.
Thank God.
B's a PERT. Do you like PERT?
No, I'm just like a little confused on like the other one because I just get the like letters confused. Like how to set it up. I don't know.
Yeah, that might be a math thing.
It probably is, you know? So.
But B is PERT. P equal, I'm sorry, that's not, A equals PRT, right? PERT. Ooh. For A, PERT formula, right? That's always continuous. That's a derivative function in calculus that produces that. And then the last one says, okay,
Is it P-E-R-T or N-T?
It's
PERT. So that's E. This is rate in decimal form times time in years. And P is your investment principal. All right. So I think those are the trickier ones. You're looking at 6.2. I'm hoping that on 6.2, actually that's probably worth looking at. Do you guys see